All right, let's look at x approaches 2 again. Here's one list. Here's a different possible x approaches 2 list. Notice that this first list, all the numbers in the list come from the positive end of the number line, whereas all the numbers in the second list, they come from the negative end of the number line, or the negative half of the number line. So that inspires a convenient notation for indicating numbers in a list that are approaching 2 coming from that positive half of the number line, or numbers approaching 2 coming from the negative half of the number line. Here is another kind of list, and you'll notice that everything keeps getting bigger and bigger and bigger as we go down the list, and there's no biggest number in the list. With this kind of list, we would say that x is approaching infinity. So here's another kind of list going out in the opposite direction toward minus infinity. And so we have a nice notation to describe this situation also. All right, suppose that we have ourselves a list where the numbers in the list are going to infinity, getting bigger and bigger and bigger. Elaborate a little bit. If I have an x approaches infinity list, we can make new lists out of an old list. I can take the old x list and say square the entries and add 1 to build a new list. Fortunately, the numbers aren't any bigger. We can see that if the original list goes to infinity, this new list is going to go to infinity even faster. Now I can sum up the two observations that we just made. If the original list goes to infinity, the list made out of using the x squareds plus 1s are also going to go to infinity. I'm going to put quotes around the equals because infinity is really not a number, but being able to say that the limit is going to infinity is conveying useful information. We could also form a list by using formula, for example, something like 4 minus x squared, which I would claim is clearly going to go to minus infinity. Let's look a little bit more closely though. The first entry in the 4 minus x squared list should be 4 minus 1 squared, so that would be 3. 4 minus 3 squared, what's that, minus 5. 4 minus 5 squared, minus 21. This is getting hard. So we can sum up by noting that the limit as x goes to infinity of 4 minus x squared is going to be minus infinity. We can now go to a somewhat more interesting example. Suppose that x is going to 0 from the positive side. We can build such a list. Now we can look at the list formed by the corresponding 1 over x's and see what happens with them. So if x is 1, 1 over 1 is going to be 1. If x is 0.1 or 1/10, then 1 over 1/10 is going to be 10. The smaller the x is, the bigger the 1 over x is going to be. Next one would be 100. They're going to get bigger and bigger as the x's get smaller and smaller. So it looks like the 1 over x list is going to be going to infinity. We can build a similar list of numbers that are going towards 0 from the negative side, from the left. If we look at the corresponding 1 over x list, it goes with a limit going to 0 from the negative side. We see that since all the x entries are negative, that the corresponding 1 over x entries are going to be negative also. So this time, the corresponding 1 over x's are going towards minus infinity. So to sum up, the limit as x approaches 0 from the positive side of 1 over x is infinity. the limit as x approaches 0 from the negative side of 1 over x is going to be minus infinity. Notice that we're getting different limit values depending on which side we approach from. If I just write the limit as x approaches 0 of 1 over x, it is not supposed to matter as to which side the x is approaching the 0 from. If we demand that there be only one limiting value, then the best we can say here is that the limit as x approaches 0 of 1 over x is undefined. There are various ways of saying this.